Welcome back. So let's continue. So we were counting the file. Now, we can also apply a filter. This is also not new to you. I've already showed you that, right? So now I'm just taking the collection. And again, imagine there's 2 billion items in there, right? $.type equals push events. I'm just filtering, looking for only those objects that are of type push events. And it's returning, like this is the first one here, but it's going to return all of them, right? It's just a filter. That would be like a select from where. It's compact, right? But this is basically like a select star from Git archive where type equals push events. Okay. Okay, that's navigation. So now you know how to navigate to objects, to arrays, and navigate down and ask for keys and eliminate eliminate duplicates and so on and so on. Now, how do we construct data out of nowhere, like constructing numbers on a calculator by typing them? Well, it's actually super easy. The trick is this: take any JSON value, anything, a string, a number, a Boolean, a null, an object, an array, anything. This is JSONic. You can literally copy paste it into JSONic and that works. You can try it. So this is JSONic. Obviously, it's trivial, right? That returns a sequence of one item that is the string foo, but it's not, again, it's JSONic. It's not just JSON. These are 3 JSONic queries. It uses the same escape sequences as in JSON with the backslashes, exactly the same. These are 3 different queries, and each one of these 3 queries returns a string. Now, how do I return numbers? Well, exactly like JSON. I literally copy-paste JSON numbers, and that returns. So these are 3 queries. The first one is returning an integer. The second one is returning a decimal. Remember the data types from the data modeling lecture. And the last one, because I use the scientific notation, so it's just going to return a double, right? Okay, so that's how I construct number. Literally the same syntax as in JSON. Booleans, easy as well. Again, this is JSONic. So the query on the left returns a sequence of 1 Boolean, that is true, and the query on the right returns a sequence of 1 Boolean, that is false. Now, how about the other types? Wow, other types, yes, because we saw in the data modeling lecture that we don't only have this 4 primitive like string, number, Boolean, null. We have like 20 plus atomic types that I presented to you. Remember these huge tables where I was showing to you, these are all the XML schema types, the JSON types. Well, the JSONic types are exactly the same ones as in XML schema in JSON. There is nothing new in there. It's exactly the same type you already know that are listed in the data modeling lecture. And to create them, it's easy. Just put a value, for example, a string, the literal of the value, and then put it in something that looks like a function call. That's called a constructor, basically. So, for example, I construct the last one, a non-negative integer out of 42. It has the type non-negative integer. And these are all the others. Again, these are all the types that we had from the data modeling lecture, so that's not new to you, but this is how it works. You put a literal in a string, and just say the type you want, and that's it. For whom is it clear? And again, the list of types is not even new. This is the one we saw a couple of weeks ago. Okay. Now these are atomic values. What about objects and arrays? Exactly the same. You can pick any JSON object, any JSON array, literally copy paste it as a JSONic query, and it returns itself, right? So this is an object. Sorry, this is not an object, this is an array. There's square brackets here. This is an array of 2 objects. And again, it returns itself. If you put that in JSONic, that's the same output. Now, because this is one item, right? How do I construct sequences then? Well, I construct them with commas, just using commas. So here I say an array, comma, true, comma, string, comma, an object. This is a sequence, this evaluates to a sequence of 4 items, an array, a Boolean, a string, and an object, right? Just with commas. And again, that I already showed to you earlier, another way to build sequences, in that case, sequences of numbers, is with these 2 keywords, right? So 1 to 100. And by the way, you will notice that if you try to do this with a very large number, like 1 to 10 million, RumbleDB will automatically spread it in a parallel fashion. Automatically. without you saying anything. It automatically detects this is a huge number, and so it's a huge sequence. And you know what happens to huge sequences? It's like RDDs. RDDs are spread all over the cluster. Well, the same happens with huge sequences here. Right. Okay, now what else can I do? Well, I can do arithmetic. No big deal. Every single programming language has that, right? So I can take a sequence of one item and add it with a sequence of another item. So 1 + 1, for example. I can subtract, multiply, divide. Be careful, that's not a slash, it's div, just for legacy reasons, because the slash was used in XML to navigate in XPath. Integer division, I div, modulo mod, right? I don't think I need to say much about that. It's just like a calculator, regular arithmetic. But I do need to say that because sequences can be empty, if it's an empty sequence here, then the addition returns the empty sequence as well. It's similar to SQL. In SQL, when you have null, null + 1 returns null, right? Okay. What happens if I have if I don't have the right type? An error. If I try to add foo with 2, it's an error. Don't confuse that with languages like Java that will try to convert 2 to a string and concatenate, right? Don't be confused with that. Here it's an error. You cannot add a string and a number. What about if one of the sequences has more than one item? Because the sequence can have millions of items, right? What if I try to add that to something else? Well, that's also an error. You can only add one single item to one single item, or 0. Right? Okay, so this is for numbers, right? What about strings? Well, for strings, typically, it's like in Excel, actually, it's typically a library. You have libraries that allow you to extract the first characters of a string, the last characters of a string, characters in the middle of a string, to find characters in a string. You can concatenate strings and so on and so on. So there is a very large function library, subs, string join, string length, and so on. This is all a standard. This is all a W3C standard that you can find online. It's linked from the documentation of MongoDB. This is all, it's called the XQuery and XPath and XQuery function library. But it doesn't matter that it's XPath XQuery because it's the same for JSON. It doesn't matter if it's XML or JSON, right? So this is all standardized by very smart people. Yeah. Okay. Now, this is also something you might be familiar with from programming. You can compare things. You can compare number. You can compare for equality, inequality, greater than, less than, greater or equal, smaller or equal, and so on and so on. So the little ticks on the right say true or false, right? So 1 + 1 = 2 is obviously true. 6 × 7 is not the same as 21 × 2. That's obviously false because it's 42 on both sides, and so on and so on and so on. So this is comparison, right? Super easy, right? So the syntax should not even surprise you. If you try to compare a string to a number, it's the same as addition. You throw an error. You cannot compare a string with a number. What about sequences of more than one item? Well, you might have thought, okay, also an error, right? Just like arithmetics, but actually not. RumbleDB is actually smart to figure something out. In fact, I'm going to use formalism, but don't be scared. If you use the comparisons on sequences of more than one item, it actually performs an existential quantification. It means, so that's the scary words, but just for saying that it looks on the left and on the right, can it find one item anywhere on the left and one item anywhere on the right that compare in the desired way? Here, yes, the answer is yes. You have one on the left and one on the right, and 1 = 1, right? So that's going to return true. It would also do the same if you put a 2 or a 3 on the right, it would still return true. This is what I call an existential quantification. Who has already seen this inverted E in math, right? The E but mirrored. Who already saw that? Right? It's the same thing. That's an existential quantification. Here, for example, this is true too. Why? Because again, you only need to find one item on the left, one item on the right that match the comparison, right? So here I pick 1 on the left and 3 on the right. And is it true that 1 is strictly smaller than 3? Yes, that's enough. I just need to find one match with 2 items. This returns false. Why? Because you will not find any item on the left that would be greater or equal than any item on the right. Who agrees with that? There is no way you will find that here. But you need to really check there is no way, because otherwise you cannot say with certainty that it's false, right? Okay, so that's the idea. And again, if you have strings and numbers and so on, that's an error, right? So that would return an error. Okay, what about the empty sequence? Well, it's just the logical semantics of the existential quantification. Can you find an item on the left that matches an item on the right? No, you cannot even find any item on the right. There is nothing on the right, right? So this is why it returns false. Why is that useful? Why did we even bother to extend the semantics of comparison to sequences of more than one item? Because that looks a bit scary, right? There is a reason. It's actually very convenient, because this is a common use case when you query a data set. Imagine that you want to find out in a huge data set with billions of items, if one of the values associated with name would be Switzerland. Well, you can do it in a very compact form. All you need to do is JSON file blah, 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 dot name. It's going to return a sequence of 200 strings. In that case, there's not billions of countries, of course, but 200 strings. And equals Switzerland is just going to return true if at least one of them is Switzerland. And that's the case here in the example, right? Because Switzerland, the first one matches. So this is true. For whom is that? Does that make sense? Okay. This is only a convenience. Okay. And if you don't like that, because maybe some people don't like it, there exists another way that I didn't want to bother you with that, but there is also an explicit syntax that basically says some $I in JSON file blah, blah, blah name satisfies $I equals Switzerland. That's a very verbose way of saying the same thing, right? That also exists, but this is just more compact. Okay, what else? And or not. That's just the classical logical thing that the logic thing that you have in almost any language. Even Python, Java, they all have that, right? They might not use and or not. Like in Java, you have this double ampersand for and, you have the double vertical bar for or, and so on, right? But the logic is the same, right? Conjunction, disjunction, not, and typically it's used together with comparisons very often. Okay. So we already covered a lot, right? We can navigate, we can construct, we can do some arithmetics, we can do some logic, we can do some comparison and so on. We even have for loops, filters, and so on and so on. So that's already a lot. We are not done, there's others. But you see, it should start feeling like a Lego game, right? I'm just giving you building blocks and you can just compose them. And in fact, that's how it works, because there is this rule of thumb that says you can pick absolutely any expression and put it anywhere you want inside any other expression. It's fully generically composable. And here's an example of that, where I have something complex. We are going to evaluate it together, step by step, just to show you what happens with RumbleDB. 2 plus 2 is, just checking you're following, 4, right? Okay. So now I have this object B, blah, 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 and I do dot B. So dot B is going to extract the value associated with B. So that's an array, right? Now I have an array with one object. I pop it open with this square bracket. It opens it. So that takes the object, right? If I open it, dot A is going to return 4, right? Because A is associated with 4. So that evaluates to 4. 1 plus 4 is 5, and 5 to 50 is just the sequence. Who followed? Okay. That's the idea. So it's fully composable. And here I did it with simple expressions, but you can do it with absolutely any other expression. Of course, you might get errors, right? If you compose them in a way that doesn't make sense. But the general rule is that you can. Now, I'm sure you've seen, probably not in primary school, but maybe at least in junior high school, that if you, let me try that. How much is 2 plus 3 times 4? Anybody? On Zoom, maybe, unless somebody in there. How much is 2 plus 3 times 4? Nobody? Okay, who says it's 20? Who says it's 14? Okay. And why did you do that? Because you know that multiplication has precedence over addition, right? Well, it's the same thing here. There is a precedence rule as well, that not just multiplication and addition, which is true as well, but all of the others. So for example, the comma is the lowest ever precedence, right? And the highest precedence is function calls and so on. But don't worry. because you don't actually need to worry too much about that. If you have a doubt about the precedent, just put parentheses. It's never a problem to put parentheses, right? So if you're unsure in what order the precedents will be evaluated, add parentheses all over the place, and that's it. Then you're safe. Okay? So it's not important that you know that by heart, basically. That's what I'm saying. Okay. And that also comes with practice of the language. Here's another example of composability. And here, I hope that you will see how now powerful this is getting, because until now, I told you you can copy paste objects and arrays in JSONic, right? But that was very boring, right? You just return it, right? JSONics can make it dynamic. What do I mean with that? Look at this. It looks like an object, right? It looks exactly like an object attribute, but look, this is not JSON. String length, that's not JSON anymore. That wouldn't parse as JSON, right? What about values? So that looks like JSON, then there is an array, but look inside, for blah, blah, blah. That's not JSON. That wouldn't parse as JSON, right? This is actually because instead of JSON values, I put JSONic queries. And what's going to happen is that they will be evaluated, they will return something, and then you build JSON out of this. So it means concretely that the string length foobar that's going to be evaluated to 6, because there are 6 characters in foobar, and now the output will have at 6. And values, it's an iteration for $I in 1 to 10. So we evaluate long $I between 1 and 10. That's building a long integer. And then I have 1, 2, 3, 4, 5, blah, 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 and I put them in an array. Now this is JSON in the output, right? Who understands that the query returns what there is below? Right? It's dynamic, it's declarative, right? This is the power of a declarative and functional language. And that's how it works. You can just use it, that's like a calculator thing. Okay. Now, here's a few more other expressions that you should be familiar with if you already learned other programming languages like JavaScript, Python, and so on. Because there is an if then else. That shouldn't surprise. Who already saw an if then else? Raise your hand. Nobody? Okay, you were just shy. Okay, so many languages have that. In JavaScript, in Python, and so on. What it means is that you evaluate what there is in the if. It's either true or false. If it's true, then you return whatever is after then. And if it's false, then you return whatever is after else, right? So in that case, we count the number of countries. Is it more than 1,000? No, of course not. There's not more than 1,000 countries, right? So this is going to output small file. That's an if then else. Okay, but it's a functional version of an if then else. Then we have the switch case. It's more like a lookup thing. Imagine I have a code and I want to look it up. So I just put here some sort of catalog that associates the languages with every country code. So for CH, I'm going to say, okay, that's German, French, Italian, Rhetoromanisch. I don't know what I meant with GSW. Was it maybe a typo or something? Anyway, oh, Schweizerdeutsch, maybe. I meant that. Okay, F, French, Germany, German, Italy, Italian. Of course, that's just made up and so on. Of course, there's people who speak German in Italy and so on, right? But just to show you that you can map country codes to things. And the switch is just looking it up, right? It's evaluating the country code, and it's just looking it up in the list of the cases and returning what corresponds to your case. For whom is that clear? Right. This is not the most important expression. I don't think many people use it, but it can be convenient whenever you have something that requires a lookup. There is also the try-catch expression. It's also something you use more rarely, so it's not something that you might use every day. It's just that in case an error is returned, you might want to catch it. So instead of throwing it at the user's face, you might catch it and return something instead. For example, imagine here we try to cast a country code to an integer. It might not work because the country code is not an integer. That would return an error. But if I catch this error, then instead of throwing the error, I'm going to return a string that says the country code is not an integer. That's the try-catch. It also exists in many languages, Java, JavaScript, and so on. Okay, but again, as I said, these are rarer. You might not even need them. It might be you don't even need them for the purpose of the exercises and the exam. But just so that you know that they exist, right? If then else, you might need. This is quite convenient, actually. Okay. Now, imagine that I'm coming back to my data set now, and I navigate it down to .payload.commits. What I notice is that this seems to be a sequence of arrays, right? And these arrays contain objects, but this is a sequence of arrays. What I can do is unbox this sequence of arrays. What happens is that it extracts all of the objects in size and flattens it back. So now I extract all of the objects and get this. It's very similar to the explode function in Spark SQL, right? Okay, and then I can continue with .author.email, and that basically just navigates in there, right? So you get the idea of how navigation works. And again, do it. Take the data set, try to do these things. You will see, and that's the best way to get familiar with it. There is also a convenient way of testing the size of an array. Of course, what you could do is open the array and then count, right? But if you directly want the size, you can use the size function. So payload commits is an array every time. And here, for every one of these arrays, we look at the size and see if it's greater or equal to 5. What that means is that all of these lines for which the array has at most 4 objects in there, we just discard them, we ignore them, and we only keep these objects for which the nested array has at least 5. How many do we have? 5,643 out of 200,000, right? Without the filter, I would have gotten 200,000, but if I filter based on the size, I get that. So that's just an example. Now, another example of the sort of things that I can do is that I can, instead of opening the entire array, I can say, I only want the first item of the array, the first member of the array, right? I can do that with this double square bracket and a number, right? So double square bracket 1 is going to extract the first commit, not all of them, just the first one. So every time I take the first one, and then I look at the email of the author of that commit, right? And I can even look at the distinct values. So that tells me how many email addresses there are for the first committers. Who agrees? Okay. All right. Now, then I'm going to push you a bit further. These queries here can be not so easy to read. There's a lot of nestedness, there's parentheses, and so on and so on. So for a human, I mean, for a computer, it's easy, right? But for a human, this is hard to read. It's also hard for me, and it's not getting better as I age, right? But there is a simpler way here to do a cascade of lets. Instead of having this huge, big query where you nest things, you just do it step by step. First, what's the path? It's git-archive-big.json. Then I get my events. These are those coming from JSON file. $events will be a sequence that potentially contains billions of items, right? In a single variable, you can do that, right? So events is a huge sequence. Then actors is events.actor. That's also probably a huge sequence. The logins also. Distinct logins take the distinct value as logins previously defined. And finally, we return the count of the logins. So it's a very convenient way where you do it step by step. And at every step, you bind to a variable. And then in the steps after that, you can use that variable, right? So I use $path in JSON file that was previously defined. I use $logins in distinct values that was previously defined with another let. And so it's a common pattern to do let, return. You cannot have a return without any let or for, right? It has to be at least with one let. Okay, for whom is that clear? Cascade of let, very convenient. This I strongly recommend. It will make it much easier for you to solve queries and to keep your sanity if you try to do it in these steps like that. Okay. Now there's not only let, it turns out that there is also a for, and what the for is doing is that it's iterating. Instead of directly binding once to the entire sequence, it's going to create it one per item. So in that case, $events is going to take in turn each one of the lines, the first line, and then the second line, and then the third line, and so on. For every one of these lines, 2 billion lines, let's say, I evaluate the size of the commits and store it in NB commits, but I do it 2 billion times. And then again, 2 billion times, I return an object with ID that is the events.id taken from the current events, and the number of commits taken from the let variable. And then I return this, all right? So we have let and for, right? And for iterates, let just binds it once. Okay, which brings me to flower expressions, because actually this here, for let blah, 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 is called a flower expression. Well, why flower? Look, let that starts with an L, returns that start with an R, so that's the L and the R of flower. F that starts with an F, so I have FLR, FLR, and W is for where, and O is for order by, and it's called flower. I think it has to do with the fact that one of the creators of xQuery, which is a language during JSONic, her name is Dana Florescu, and that might be, I suspect that this is a hint in recognition. All right. So the let clause. Well, I already explained, right? $x is bound in that case to the item 2, and then you evaluate x times x, you get 4, right? It's an easy one. 4, you iterate between 1 and 10, 1, 2, 3, blah, 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 blah. For every one of these, you bind it to $x. But again, it's a for loop, so it's 1 at a time. First 1, and then 2, and then 3, and so on. And then you evaluate this object 1 at a time for each one of from 1 to 10, and you get this sequence of 10 objects. Who understands this query? Okay. Now, here's the where clause. This is new. What is the where clause doing? Well, the same thing as in SQL. It's actually filtering out those that do not fulfill the predicates. So in that case, I'm iterating for all integers from 1 to 10, where x minus 2 must be more than 5, strictly. It's another way of saying it's more than 7 strictly. X is more than 7. So what is going to happen here is that only 8, 9, and 10 are going to pass that filter. 1 to 7, they don't make it, because 1 to 7, the where clause is going to be false. So 1 to 7, they just are thrown away, discarded. Only 8, 9, and 10 pass the where clause. And when you arrive at the return clause, you have 8, 9, and 10 that are left, and you compute the squares. Who agrees? Okay. So we have 4, where, let, order by. It turns out that sequences are ordered, right? So in that case, I'm going to iterate over all the countries. So X is bound in turn to every country, one by one. So I have 200 bindings for $X. And then I have order by what? By X.population. So I'm basically sorting the countries by populations, descending, and then returning the name of the country. But now it's ordered by population because of the order by. And so, of course, I get India, China, United States, Indonesia, Pakistan, Brazil, and so on and so on. Right? Recently changed, just a few days or weeks ago. Now it's India. All right. So group by, it's not in flower because that one was actually added a bit later, but it's also part of the W3C standard. Well, I think it shouldn't surprise you that it does the same thing as the SQL group by, more or less. It's a bit more powerful than that, but in essence, this is like a SQL group by. So now, let's take this $X in JSON file country. So X is bound in turn to every country. Group by continent is going to basically create groups, 6 groups, if you consider there are 6 continents, so 6 groups, 1 per continent. And what happens to $X after the group by is that now $X is a sequence. It's the sequence of the countries that are with the current continent. So it's 1 continent at a time now after the group by, 1 per continent. But now $X has the sequence corresponding to that continent. So now for every continent, because I'm after the group by, I return the code of the continent and the list of countries. And in countries, I have $X.name. But again, $X now is a sequence because of the group by. This is something SQL cannot do. In SQL, when you have a group by, the only thing you can do with columns is aggregate, sum, count, and so on. In JSONic, you can actually, everything else becomes a sequence, the other variables, and then you can just very conveniently list the country names by continent. You see how this is not in normal form. This is not a relational table. There is nestedness in there. We have an array of strings. This is a data frame. Who sees that this is a data frame? Right? There is a first column that is a string. The second column is an array of strings, right? So it's a data frame. Okay. And I nested that, by the way, inside an array, inside an object with the key continent. But the only reason I did that is to show you the composability, that no matter what you have, even a flower, you can always nest it into some bigger query. Okay, So now I explained it waving my hands, but there is actually a theory behind the way it works, and I have visuals that should make it very easy for you to understand how they work. Because what for does is visually, it's as if it were creating some sort of data frame or table like this, where you have a column X, the name of the variable, and all the values one by one that it is bound with. Where is going to evaluate again in another column false and true. It filters out those for which it's false, and then $x evaluates the square based on 8, 9, 10. So that gives you 64, 81, 100. We've seen it before. What's new here is the visual. I'm explaining it in terms of manipulating behind the scenes. This is hidden, right? This thing that looks like a data frame. It's called the tuple stream semantics. This is only visual. This is how the specification says that this is done. The only reason I'm showing to you this is that, unlike SQL, for let, where, order by, return, you can mix and match in absolutely any way you want with just two constraints. It must end with a return, and it must start with a for or let. Apart from that, you can do whatever you want. For example, you can do for, where, let, group by, let, group by, let, order by, let, where, order by, group by, let, for, let, group by, where, return. That's a valid for our expression. You just need a for or let at the beginning and a return at the end. So of course, in the simple cases that there is just a very short expression like this, it's very intuitive, but then in the case where you have a cascade of 10 clauses, it might become complex. And so this is when having these visuals actually can help, right? Okay. Here's now, so that was for, here's and let and where, sorry. Here's what let does. So now I have for X in 1 to 5. So visually it looks like this. Let $y creates another column with X minus 2, like this. And then I compute X times Y and I get this sequence of items, right? Again, the two things here, the blue tables, they do not really exist. These are not values in JSONic, it's only a visual. What is on the right is the sequence of the 5 items that the flower expression returns. Okay, here's another one. For $x in 1 to 5, that you know, group by, so it's first computing Y, it's computing the key, X mod 2, so that's just the remainder by the division of 2, 1 if it's odd, 0 if it's even. And then group by does this. This is what it does. Look at what happens. Y, there's only 1 or 0, right? So I have two groups, the groups for which Y is 1 and the group for which Y is 0. And what happens to X is that I group it. What was associated with Y equals 1? Well, 1, 3, and 5. What was associated with Y equals 0? Then 0. So I have the sequence 2 and 4. This SQL cannot do. Well, extensions of SQL can, right? But normally, this is not something you can do with SQL. In SQL, you would have had to compute the sum or the count or the max of X because you could not have a sequence, because that's not in normal form. This is not an atomic, this is not the first normal form on the right. It's denormalized. Okay, and then the return, who 1 or 0, that's Y, and then the count of X. So in the first case, there are 3 values in X, and then there are 2. Who understands what this does? Okay, this is what group by does. It's very, very, very convenient, right? Okay, and then you can also sort like this with order by. So now I'm coming back to my data set. So you can order by descending commits and then project just on ID and type. By the way, this is how projection is done. Just call the project function and list the columns that you want to keep, the keys you want to keep. So here, just ID and type. Okay. Grouping, that's another example where you group by the number of commits. This is called a histogram, what I'm doing here. I'm basically grouping by the number of commits, and for every group, I'm counting the number of events that have that many commits, right? So the number of commits is based on the size of the nested array commits, right? So for this event, there might be 10 commits. For these other events, there might be 5 commits and so on. So I group my events by the number of commits. I order them by the number of commits. It's very common to actually have group by immediately followed by an order by, just like in SQL. You can also have group by, order by. And then how many events do I have with no commits at all? Well, 90,000. How many with 1? 92,000, and so on and so on. And I can actually take that, put it in a spreadsheet software, and build a nice chart, right? That's the idea of, in fact, this is now data science, right? It's the sort of thing that you can then do and visualize. Okay. So just more examples. Again, I'm throwing all of that at you, but this is all in the tutorial that I showed you at the beginning with the try it out in the Jupyter notebook. So you can really try this and see for yourself. Imagine I have these two data sets, products and stores. The idea is that we want to join them on the ID, right? Every product is linked to a store via the ID. So what I can do is select, for example, I'm going to retrieve the entire relational algebra like that. Selection with a where clause. Here I'm selecting where the store is one. Okay. Now I want to project on just ID and type, right? The products, they have ID, type, and store. If I project on ID and type, then I get this. This is projection. So selection, projection, ordering, I do it with order by. We've seen that. Aggregation, something else you can do with SQL. You can do it with group by. In that case, you could do it with SQL because I'm using a count here. So if I use an aggregation, these are things that SQL can do too. So here I group by type and I count for every type how many products there are. So there's 4 TVs, 1 phone, and 2 teapots. Okay. Then I have joins. What is a join in SQL? It's when you have select from with 2 tables. And then in the where clause, you can put the predicate. Well, that's the same here. For every product and every store, where the store matches the ID of the product, because you need to, the store of the product matches the ID of the store. That's my join criterion. And now it's combining these 2 data sets. See, for example, the first one, store the TV, it's a TV in store 1. Store 1 is in Switzerland. So I'm going to get out of that TV in Switzerland, right? And so I get, normally, if I did my work correctly, TV in Switzerland. I joined these 2 data sets. So you can do that as well. Left outer join, it's more complex. You don't have to worry too much about this because at the exam, you anyway have a single JSON file. So it's not like you will have to join it, right? But just so you know, there is a special condition called allowing empty in the for clause that makes sure that in the case that there is no match, it might happen when you join. There might be no match, right? If I go back to the data set. Imagine that you have a store 4 in products, and there is no 4 in the IDs of the store. Then you have no match, right? So normally in a normal join, that would be thrown away because there is no match. So it just disappears. But with allowing empty, you prevent it from being thrown away. So you basically say the stores with a filter that the product store must match the ID of the current store. Allowing empty means that if there is no match, you just get S that will be empty and S country will be empty, right? So country will be empty, but you know that in JSON, you cannot have empty, right? If you have in JSON, you have a key, you cannot leave empty after the colon. So what it does is that it has null, right? If it's an empty sequence, automatically adds a null. This is called the left outer join, right? This is advanced. Don't worry too much about that. This is really something advanced. I even hesitated if I should show it to you because this is, again, more for computer scientists. But just so you know that this is the sort of things that you can do. And finally, you can denormalize. What do I mean with that? Stores.json and products.json, these are tables, right? This is tabular. Atomic integrity, domain integrity, this is all flat and homogeneous here. But denormalizing, I mean by that I combine them in a way that now I have something with nestedness, right? For example, I can try to look for every store. For every store with the let clause, I select just the products that match the store, right? And then for every store, I list them, p.type. So in Switzerland, there are 2 TVs. In Germany, there's a TV, a phone, a teapot, and another teapot. And in the US, there's a TV. This is now denormalized because I have nested strings in the array, right? This is called denormalization. You cannot do that with SQL. Okay. Some more thing that I can do is types, because there were no types until now. I just declared my variables without any types. In fact, in Python or in JavaScript, it's the same. You don't have to declare your types there. But if any one of you use Java or C++, you might know that you need to describe types in Java or C++, right? So it depends on the language. Well, in JSONic, it's optional. If you want, you can. If you don't want, you don't have to. So this here, what I did is I just took a query that I've shown you before, and I just added type information. Path is a string. Events is a sequence of objects. This little star means any number of. Actors is a sequence of objects. Logins is a sequence of strings. Distinct logins is a sequence of strings. Count is an integer. And now I'm safer because if the types are not satisfied, I'm going to get an error, and then I can fix it. So it's safer, basically, to add types in there. All right. How do types work? Well, it's first, that's the same names that you've seen before in the data models lecture. And I think the occurrence indicators, I also showed them to you in the data modeling lecture. And here they are back. Question marks mean 0 or 1. Plus means 1 or more. I don't allow the empty sequence with plus. Object star means any number, 0, 1, a billion. And this is how it works. And I can put them in my query. Whenever I have a variable, like a let variable, a for variable, I can just put the type in there. And that's just going to check things and throw an error at me if it's not correct. So this works. This is a sequence of at least one array. This works. Instance of also works like in many other languages that checks, is that a sequence of integers? Is it true or false? It's false, right? The second one is not an integer. So 314 foo is not of type integer star, right? So this is false. Okay. Castable tests for castability, if you can change the type. So 314, is it castable as a double? Yes, absolutely. You can have a double that is 3.14. You can also have functions. This is also something advanced. So you can define your functions functionally, and in your functions, you can optionally say the types of the parameters, threshold, objects, and of the result. So in that case, I'm taking a threshold, I'm taking a collection of objects, object star, and I'm just looking, is there more objects than my thresholds, right? And then I'm saying true or false. It's a Boolean. Okay. Now, even more advanced, even though you got a sneak peek of that a few weeks ago, coming back to this histogram, do you remember the histogram that I showed you here? Where was it? Here. That's a histogram, right? A histogram is just that we have buckets, the number of commits, and then we have counts, and then you can plot them as charts with vertical bars. But in order to do that and export it to Excel, you need to use CSV. Because otherwise it outputs JSON, right? So how do I create a CSV file? Well, in order to create a CSV file, it's like Parquet. I first need to validate it. I can only create a CSV file if I have a schema. So I'm giving a schema here. What's the schema? Commits is a short. I could have put int or integers. I'm just playing with data types because it's fun. So commits is a short integer. It means smaller than 65,000. And count is a long, right? And again, I could have put commits integer, count integer. That would have worked too. And then what do? I take my query that I had before with for order, group by order by return, creating the histogram. I validate it as local histogram star. Validation just checks, is it integers everywhere? Yes, absolutely. So it works. And then I can actually ask RumbleDB to output it as CSV, because then I'm just going to put my query in a file. And then what I do is I say output format CSV. I want a header like this. And I want one partition is just to have everything in a single file. And this is an example. I actually executed that. And I opened it. In that case, that was with Apple numbers, but you could do it with FreeOffice, LibreOffice, Excel, whatever you want. Okay. So this is the sort of things that you can do. And you can take some messy data set. That was a super messy data set, Git archive. It's very nested, heterogeneous. And out of that, I created something that is in normal form and exported it to CSV. So it's like a Swiss Army knife of data, if you want. Okay. So now it's 10, so I'm going to stop here. The slides that follow is just some physical details about the architecture, if you're interested, and maybe I'll explain it to you next week, and then next week we'll have the final lecture and conclude everything. But basically, as far as learning JSONic is concerned, I pretty much did it. The chapter in the textbook is not completely over, but I will try to finish it. But again, look at the lecture, do the tutorial in the web page that I've showed you earlier, and that'll be it. So I hope you enjoyed it. Thank you very much, everybody. Thank you, Wenxi. for moderating. Do the exercises, really, there will be this at the exam, the practical exercises. The best way to learn is to just do it. Put yourself in front of a Jupyter notebook and run queries. That's the best way. Thank you very much. See you next week. It's the final lecture. I might manage to do some quiz game also so that we have fun together. You can play against the TA team for your knowledge of the course. I can answer exam questions. We can rehearse a little bit the material together. So try to come as many of you as possible in the lecture hall or on Zoom, and we will celebrate the end of the semester. Thank you very much. Have a good rest of the week, and goodbye.